we go. So, 11.5, we are talking about triangle theorems and parallel lines. So, I have a couple definitions for you, and then we'll get into it. We have, because we're going to be dealing with triangles, we have what is called an exterior angle. It's pretty self-explanatory. It is an angle on the outside of the triangle. So, but we'll get a little more specific than that. So it's an angle formed by a side and an extension of the adjacent side. So, for example, if I had a triangle and I extended one of the sides out, this would be your exterior angle. Does that make sense? So it's the angle that if you extend one of the sides of your triangle, it's the angle that is formed by that adjacent side of the triangle and the extension. Okay. We also have what is called remote interior angles. They are related to the exterior angles. So they are the two non-adjacent interior angles of an exterior angle. So I'm going to draw the same picture for this example. So if I have a triangle, so we're looking for the angles that are non-adjacent and on the inside of the triangle. So the two angles that are non-adjacent, adjacent means touching. So can I use this one right here? If this is my exterior angle, can I use this as an interior remote angle? No, because it's adjacent, right? So which two angles are non-adjacent? The two opposite ones. So this one and this one. Those are called the remote interior angles. So that guy and that guy. Does that make sense, guys? So the remote interiors are the angles that are on the opposite side of the triangle from the exterior angle. So from wherever the extension is. Okay? So like I said, for 11.5, we're talking about parallel lines and how they relate to triangles. Postulate 12 is called the parallel postulate. It says that through a point not on a line. So if I have some random point hanging out, there is one and only one line parallel to the given line. So if L is the given line in your picture, and I have some point P, there is only one line that I can draw through P that will be parallel to L. Okay? That should make sense, right? Because there's an infinite amount of lines you can draw through a single point. Only one of them will be perfectly parallel. Okay? That's the parallel postulate. There are no proofs in this one. Theorem 16 is one that we have proved. It's one that you guys have been dying to use. Now you are allowed to use it. It is the triangle sum theorem. The triangle sum theorem says that the sum of the measures of the angles of a triangle is 180. Okay, so in this example, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. So we're going to do a couple problems using the triangle sum theorem. So let's look at number 1. I want to know in this triangle what are the values of x and y. Now here's something that I want you guys to be aware of. I know that you can do all of this using a calculator and nothing else. I am aware that some of you can do this in your head. Does that mean you should? No. You do need to show your work on here so that I know what you are doing. Because if you just put a number, even if it is the right number, I will not give you full credit on anything. Okay? So I'm going to show you how I want you to show your work. So number 1 wants to know what the values of x and y are. So let's look at our picture. I notice that for x, it's in a triangle that already has 2 other angles listed, right? So x is probably going to be the easier one to solve for. So let's do that one first. So the way I want you to show your work, you have 43 plus 59 plus x, and those should all equal what? 180, because they form a triangle. Right there. Okay? So 43 plus 59, what does that give you? 102 plus x equals 180. And then how do we solve for x? Subtract 102. So what do you get? 170. Just 78. There you go. Okay? Huh? Yep, that's exactly what I was going to say next. So then Kiki says, aren't x and y supplementary? Yes. So how could we solve for y? Do 180 minus 78, right? Where do you keep getting 59?
I give up. I'm dying.
It's 78. Okay. So yes. So that's what I want you guys to do. So to do y, we would say, you could do this one of 2 ways. You could say 180 minus 78 equals y. Probably what I would do would be x plus y equals 180, because that's the definition of supplementary. And then that would be 78 plus y equals 180. So y equals 102. Okay? That's how I want you to show your work. Got it? Okay. I need to be able to look at your work and tell what you are doing and why you are doing what you are doing. Here, I'm going to move this. Okay? So then, number 2, it's the exact same picture, but they want to know what is the value of z. So z is in this triangle right here. I have 49 and a y. Do I know what y is? Yes, y was 102. So you would write that out. 102 plus 49 plus z equals 180. Little trick. I usually for z's put the little dash through it. I don't write my z's that way when I'm actually writing, but in math I do, so you don't think that it looks like a 2. I used to have high schoolers all the time that would, when I was teaching high school, you guys know how you did systems of equations? A high school thing was to do systems of equations with 3 equations, not just 2, which means there were 3 variables. So they would be solving for x, y, and z. And multiple times I had students that would make just a regular z like they write, and then halfway through the problem, they would think that their z was a 2. And z just disappeared, and it became a 2. So I always, just like I always do cursive L's, I always do a line through the z so I know it's not a 2. Christian. So then we get 102 plus 49. What'd you get? 151 plus z equals 180. And so z equals 29 degrees, right? So the other one we should have put degrees too. 78 degrees, 102 degrees. Questions, comments, or concerns? Okay, work on 3 and 4 for me, please. Okay, who wants to help me out on number 1? Jen, what'd you do? Take me step by step.
Okay. So I did 117 plus 33. And then I just put x for the measure of 1.
Okay, so she called it x. You also could put plus measure of angle 1. Okay?
And then I added is equal to 180.
Is equal to 180. Hold on 1 second. I forgot I froze it. There we go. Okay. So really quick before she moves on, she labeled the angle as x. You can also write just measure of angle 1 and use that as your variable. That is fine as well. Okay, go.
And then I added 117 and 30 to give me about 150. And then I subtracted 150 from 180, and that is equal. The measure of angle 1 is 30 degrees.
30 degrees? Thumbs up if you agree. Thumbs down if you disagree. Good. Okay. Somebody different who can help me with number 4. Rose.
So, I did 7 plus 30 plus x equals 180.
70 plus 30 plus x equals 180. Okay.
And then I added 7 and 30 and equals 100 plus x equals 180.
Mm-hmm.
And then after that, I minus 100 on both sides.
Okay.
And I got x equals 80 degrees.
You got x equals 80 degrees. Thumbs up if you agree. Thumbs down if you disagree. Okay, Rose. And then what did you do for y? Or did you not see that part?
Yeah.
I know
Okay, who can help me out? What did we do for y? Emily.
I used the vertical angle theorem, and then y would automatically equals to x because there's an image
Mm-hmm. So y also equals
to 80 degrees.
80 degrees. Good. Okay. So they're vertical angles, so we can just say y equals 80 degrees. Good. Any questions about that? Okay, so we have one last theorem. Sorry, Jenna. Last theorem is the triangle exterior sum theorem. So the triangle exterior triangle exterior angle theorem, says that the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So in this picture, which is the exterior angle? Angle 1. So we would say that the measure of angle 1 equals the sum of the remote interior. The remote interiors are 2 and 3 because they're the non-adjacent ones. So the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. I believe on your homework you are asked to prove this one, but let's kind of talk about why it works. Why would that work? Jen. Yeah. The triangle, right?
Yeah.
So guys, if we call this angle 4, let's just call it 4. Does everybody agree that 2, 3, and 4 all add up to 180? Yes. Okay. And then what do we also know about angle 1 and angle 4? It's a linear pair, so they are equal 180. They're supplementary. So if the measure of angle 1 plus the measure of angle 4 equals 180, and the measure of angle 4 plus the measure of angles 2 and 3 also equal 180, can't we say that the measure of angle 1 equals 2 plus 3? Which property did I use there? Transitive or substitution. Okay, I would say either one works, transitive or substitution there. Okay, so let's use the triangle exterior angle theorem. number 5, I have the measure of angle 1. That's my exterior angle. And it equals the sum of the remote interiors. The remote interiors are 80 and 18. So 80 plus 18. So the measure of angle 1 equals 98 degrees. I fixed it. What about number 6? How does that one differ? Rose, how does it differ? Yeah, you're going to have to find one of the remote interior angles. So we know that 59 plus the measure of angle 2 is supposed to equal the exterior angle, which in this case is what?
124.
Good, 124. So you just subtract. So Kiki, what do you get? Do it really quick. What'd you get?
I got
65?
65.
Who else got 65? I think I agree. Yep, 65. Easy? Okay. So, on the back page, you have 3 word problems. Some of these will use triangle exterior angle theorem. Some might be triangle sum theorem. I know on one of them, really, there's not an easier way to do it. It could go either, like you could do, there are 2 different ways you could do one of them. So you can work with your partner, but I want you to do the last 3 problems in this. Okay, number 7, Kevin, go for it. That rhymes.
I use the triangle exterior angle theorem.
Okay.
So since 80 is the exterior angle,
Mm-hmm.
and then measurement of angle A plus the measurement of angle B should equal 80 degrees. So I did.
Okay,
So
I see where you're going.
So since 80 is the exterior angle, I subtracted 30 from 80, and then I got x equals 50.
Okay, so I'm going to set this up algebraically. So we have x, right, plus 30 equals 80, yes? Not 180, 80. Whoa. So you subtracted 30, and we should get x equals 50 degrees. Thumbs up if you agree. Okay, Jonah, question.
Okay, this is just the picture, but it looks like the airplane's going for the control tower. It looks like it's going.
Well, I don't know. It kind of does. Sorry. I don't know. Okay, I want you to show your work this way, okay? So I do ask that you show that you are using the triangle exterior angle theorem by showing that the exterior angle equals the sum of the remote interiors. Got it? Okay. Number 8. Who can help me? Well, wait, no, I'm going to call on somebody. Isabella, what'd you do for number 8?
Number 8, I did 72 plus 90 plus B equals 180.
So she did 72 plus 90. Where'd you get 90 from?
The right angle.
Mm-hmm. Plus B equals 180. Do you know what theorem that is? Look in your notes.
The triangle angle something.
Good. So she used triangle sum theorem. Okay, so what'd you do next?
Then I added 72 and then
Okay, and what'd you get?
162.
162. Plus B equals 180. And then what?
I subtracted 162 from 180,
Mm-hmm.
and then I got B equals
18?
Yeah.
You guys agree? Okay, so then how did you find angle A?
To find angle A, since there's supplementary angles,
Mm-hmm.
in B, I did 18 plus A equals 180.
Okay, so you did 18 plus A equals 180. And you got A equals
162.
162. Did anybody do it a different way? Rose, what did you do? Okay, so you used the triangle exterior sum theorem. So what Rose did, I'm going to use a different color. So she did A equals 90 plus 72 to get A equals 162. And then you used supplementary, right? So then she did 162 plus B equals 180. And so then you get B equals 18. Do you get the same answer regardless of which method you use? Is either one correct? Yes, as long as you show your work. Okay. How many did it Isabella's way, just out of curiosity? Raise your hand. Okay, how many did it Rose's way? So about 50-50, okay? So either method is valid as long as you show your work. Okay, so number 9, you have a lounge chair that has different settings to change the angles formed by the parts on how much you want it. You guys have seen these chairs before, right? It's like a hammock on a chair. Okay. So, Jonah, what did you do for this one?
Since it was a weird card picture, I drew it again, except we replaced 2 with 71 and 3 with 41,
Okay, so he says he drew it in and he replaced 2 with 71 degrees and 3 with 43. Okay.
Then I added those and I got 143.
Okay, I'm going to stop you right there. Did you show your work algebraically or did you just show scratch work? Okay, so we want to show our work algebraically. So the method is correct, but I want to see your work algebraically. So, Dennis, can you help me out? How can I write this out to show my work algebraically? Like, read me what's on your paper.
I don't know, but I could go
You, hold on, say it again. Okay. So you use triangle sum theorem. So what Dennis did is he made that angle 4, and he did measure of angle 4 plus measure of angle 2. You can keep going, sorry. I didn't mean to interrupt you. Plus measure of angle 3 plus what? Plus measure of angle 2 equals 180. And so then I'm assuming that you found measure of angle 4 and then did supplementary angles, right? Okay. Did anybody do something different? Malika, what did you do?
I did 71 plus 43 plus measure of angle 1 equals 180.
Okay. What theorem are you using?
The triangle sum theorem.
So she did measure of angle 1 plus 743
Yeah.
plus 71 equals 180. And that is exterior angle sum theorem.
No, I used the triangle.
Okay, is that the triangle sum theorem though? Measure of angle 1 is the exterior angle.
Oh.
Okay, so who can help her out? Jen. I know the picture is not very good.
I did the measure of angle 1
Yep. That's what I would do as well. So you are using the exterior angle sum theorem, right? Okay, so the measure of angle 1 equals 43 plus 71, which gives you the measure of angle 1 as 114 degrees. Would Dennis's way have worked also? Yes. So Dennis's way, let me move it over so I can show you what he had on his paper. So what he did is then he did measure of angle 4 plus 43 plus 71 equals 180. So measure of angle 4 plus 114 equals 180. So measure of angle 4 equals 60 6, yeah. And then he did measure of angle 1 plus measure of angle 4 equals 180. So measure of angle 1 plus 66 equals 180. So measure of angle 1 equals 114. So that's what he did. Did he get to the same place? Yep. So as long as he's showing his work, which basically Dennis doesn't mine look exactly like yours pretty much. Except for this part, yeah. So if he's showing all of his work like this and I can follow what he's doing, this is also completely valid. Okay. The exterior angle sum theorem basically is combining triangle sum theorem, which is this part, and the definition of supplementary angles, which is the second part. Basically, Dennis proved the exterior angle sum theorem using an example. Okay, so your proof would pretty much follow the same steps. Question? Okay. And that's it, guys. That's a lot of theorems for this unit, right? Yeah. You're going to need to memorize them. So, this is what we're going to do next. We are going to take a quiz, and then you guys are going to get the rest of the time to work on homework and start your review. Let me stop this.